In the next few minutes, I want to dive into the concept of correlation. Two things are correlated when there's something that relates them. Yeah, that's vague, I know. But if you meet me and we start to talk and I say the word correlation, most probably I mean mathematical correlation, which means that given two sets of data describing two different aspects, there's some mathematical formula that correlate them, that relates them. Maybe we don't know what is this formula, but we have methods based on mathematics and on how the data look to determine if these two sets of data are related to each other. The method vary and focus on different aspects, but the point is that even if we don't know this formula, which in many cases we don't, because these formulas can be really involved and complex, but even if we don't know the formula, we can still say something about the correlation that there is in the data. So let me give you an example. Let's take the temperature outside and the consumption of water of someone. So these two things you can easily imagine they are correlated. So if it's warmer outside, the person most probably will be drinking more. But that's not the only reason why that person could drink more. In the end, how much you drink is due to your level of activity, your metabolism, many different things. How much you are busy, if you remember to drink, and all these things. But still, there's some sort of relation, even if we cannot really write down a formula to see how these two things are really related. We can calculate this correlation. So this is great. And as I said, this can give you knowledge by starting from the data, just starting how the data look. So if we see the temperature that is rising and then the daily consumption of water of the person going up, this is some sort of structure, some sort of pattern that relate the two set of data. But there are many types of correlation that, as I was saying, and also you can see already in my example that there's some sort of causation. So correlation is not always causation, but causation is a type of correlation. The reason why, at least a partial reason why someone might be drinking more is because the outside temperature is higher. But doesn't mean that all the things that are correlated have a causal connection. Maybe sometimes can happen that two things have the same cause. So the amount of water glasses that one consumes in a day could relate very well to how many people are going to the beach, but the two things are not like one causing the other. They have a common cause, that outside is warmer. And to dive into this type of more complex correlations, it's important to know the context. And many times the only one that know this type of context, how things work with each other, are human beings, or in some cases expert. And having all this information is very important if you want to really dive into why two things, or if two things are correlated. And now we have the fact that human knowledge might be partial. You might be into a hunt for various different aspects, and not everyone knows everything. You will have to make connection. So you might be thinking, oh great, now we have this generative AI, this LLM, they are very good in putting together things. That's true, provided that we give them the right set of documents to dive into. But one thing that they stay very, very bad is to do math. So a way to give a bit an extra tool to your LLM is really providing this LLM from somewhere else, with a tool that actually can analyze and correlate mathematically things. Because as I said, mathematical correlation is not dead, because the great thing is that relies only on the data. You don't need any other piece of information to see if there's a mathematical correlation among things. So again, the algorithm, the AI with a human touch, the combination of this LLM and other AI tools that are better in math can give the maximum result.